So this question says a certain virus grows in a community based on the model N of t equals 10 e to the 0.05 t, where n is the number of people infected and t is the number of days since the original infections. How many people were infected initially? So that would be, what is n when t equals 0? So let's take a look. There's our original equation, and that's what we're looking for. So what is n of 0? That is 10 times e to the 0.05 times 0, which is 10 e to the 0, which is 10 times 1, which is 10. So 10 people were infected initially. I'm recording this video during the COVID-19 pandemic, so I guess this is oddly appropriate. 10 people were infected initially, and what is our next question? How many days must pass before the initial number of infected people doubles? So we're starting with 10. If it doubles it, we're up to 20. So it looks like we need to find the number of days that must pass. So find t when n equals 20. That would be a doubling situation. So if that's the case, then what do we have? We'll say 20 equals 10 e to the 0.05 t, and we're going to go ahead and solve this algebraically. Divide both sides by 10, so I get 2 equals e to the 0.05 t. Now we're going to go ahead and take the natural log of both sides. Natural log 2 equals natural log e to the 0.05 t. And we know that the exponent can come down. So our next line will be natural log 2 equals 0.05 t times the natural log of e, but the natural log of e is just 1. So this then becomes natural log 2 equals 0.05 t times 1. And then I can finish this by dividing both sides by 0.05. Then we get t equals natural log 2 divided by 0.05. What does that give us? Natural log 2 upstairs. I like to use parentheses just to make sure. Natural log 2 divided by 0.05. And what do we get? 13.86. So in terms of our original question, we were wondering what? We were wondering how many days must pass before the initial number of infected people doubles. And we have 13.86, so about 14 days. So it takes 13.86 days, or about 14 days, for the number of infected people to double. Let's take a look at what this graph looks like on Desmos before we finish the problem. So again, n is 10 e to the 0.05 t. So let's go to Desmos if I can find it. I want to take a look at it. Here we go. So the function NFT, I don't know if it'll let me use NFT, but I'll try. NFT equals 10 times e to the 0.05 t. Does it like t? It seems to. So notice it starts at 10, and 14 days later, if I get to 14, it's doubled. There you go, approximately. And this is the curve. So during the pandemic, you've heard people in public health say, we need to bend the curve down. The growth rate is continuing to grow in an exponential fashion. So we've got to bend the curve down. It may grow, just not grow as fast. That was important to do during that pandemic. Okay. And we have one more question to answer. How many days must pass before 100,000 people become infected? So find t when n is 100,000. So again, we have our original equation. N of t is 10 e to the 0.05 t. We know that. We want to find t when n is a total of 100,000 people. So we started with 10. If you start with 10, can you have 100,000 people infected? So we have 100,000 equals 10 e to the 0.05 t. Let's go ahead and divide by 10. So that goes away. 100,000 divided by 10 is 10,000. Now we're going to go ahead and take the natural log of both sides. Natural log of the left, natural log of the right. So natural log of 10,000 equals natural log of e to the 0.05 t. We can pull the exponent down in front. So this comes down, we get 0.05 t natural log e. But the natural log of e is just 1. So natural log 10,000 is 0.05 t dividing by 0.05. And we have t equals natural log 10,000 divided by 0.05. Let's see what that is. Upstairs, natural log 10,000. Lost a parentheses there. 2 left, 2 right, divided by 0.05. And we get about 184 days. T is 184.2. If we go back to Desmos, if we get out to 184 days, we should see close to 10,000 people infected. So let's jump to Desmos and see if that's the case. So I need a different kind of window here. So the X value, 184 days, so I'll just take X out to 200. I don't have to go that far. 200. But the Y values, I need to go to 100,000 or a little bit beyond. So maybe 150,000. So there's our graph. And I said, when do we get to 100,000 cases? So here's 100,000 cases. What do we have? 184.2. That's about what we said. Again, it's not, the dots aren't landing up exactly, but it gives you an idea. After 184.2 days, we'll have 100,000 people infected.